My name is David Baker and I'm the lead machine learning architect here at Akeana. Today we're at the North American RISC-V Summit in the Akeana booth, and I want to show you one of the demos that we have on display here today. So in this particular demo we're focusing on the value of simultaneous multi-threading. Simultaneous multi-threading means that we can have, in this case, 4 threads running at the same time on the same physical hardware, sharing access to the execution units. Now, with the use of simultaneous multi-threading, we can often get better performance out of our programs. When you have a load instruction in your program and go to external memory, there's a long latency time, many hundreds of clocks in a lot of cases. As a result, your program just sits there idle for hundreds of clocks while you're waiting for the data you are in critical need of to come back. Nothing else happens. But with simultaneous multi-threading, if you have 3 other threads sitting around, there's a high probability that one of the other threads is ready to run and utilize your execution units. Now this doesn't make your CPU run faster than the basic rate of your execution units, but what it does do is it lets you get closer to that peak performance that your execution units are ready to do. So this particular demonstration is one from voxel processing for LiDAR. This is something that might be happening in front of your car right now today in some vehicles. The demo that we have here on the screen shows a volume 1440 by 1440 by 40 dimensions. That amounts to about 450 megabytes in main memory, in DRAM. What you'll find is that it's sparsely populated. In these applications, it's 0.01% populated, so there may only be 100,000 occupied locations out of that entire space. So our algorithm, our application today is to go to each one of those locations and check the 3 by 3 by 3 region around that location to see if there are any other occupied sites. If there are, we need to process those points together. This means that we have to touch 100,000 of these points times 26 to find out if there's any neighbors. Simultaneous multi-threading really helps with this, and you can see in our performance chart for a single thread, for 2 threads, and for 4 threads, we get a lot more performance out of this. Why? Because we're able to utilize that common shared hardware closer to the peak rate. Thank you for your attention today.